Today we are seeing an increasing need to build high-speed communication links between 2 points. For example, a company may need to build an intranet to connect between local area networks or LANs in separate buildings. Or it may wish to bring broadband internet access to a point which requires an economical last-mile solution. If you have such a need, what would you use? Copper cable, optical fiber, or fixed wireless access, that is FWA. You can rely on NTT's Wipass to provide such communication links for a wide variety of purposes. Wipass enables you to implement point-to-point communication easily and economically. Wipass stands for Wireless IP Access System. The system has been developed by NTT to provide point-to-multipoint fixed wireless access using frequencies in the quasi-millimeter 26 GHz band. It can be used to provide broadband IP services quickly and economically. In many situations, Wipass offers an ideal solution to the last 1 mile problem of optical broadband access networks. In a rural city where houses are widely separated, a combination of an optical network interconnecting public facilities and Wipass was used to provide service to a wide area economically. In multi-dwelling buildings where it is difficult to install new optical fibers, Wipass has been used to provide broadband services with simple installation work. In a suburban residential area where houses are packed quite densely, Wipass has contributed to building a network efficiently while using only a small amount of equipment. I'm going to show you examples of how Wipass can be used to provide effective point-to-point communication links. This is a variation of Wipass, which is normally used for point-to-multipoint communication. With this point-to-point capability, Wipass can be used for direct communication links, such as those providing communication between company buildings, leased lines, or backhaul links for public wireless LANs. Wipass can provide an easy-to-install and economical solution for point-to-point communication. Let's look at the main features of Wipass. Wipass's point-to-point communication can be achieved using 2 different configurations. In the first configuration, wireless terminals are used at both ends of a communication link. In this arrangement, one wireless terminal is called the master and the other the slave. The master includes a maintenance and monitoring function, which monitors and controls both itself and the remote slave. The same type of wireless terminal as is used in a point-to-multipoint configuration can be used for both master and slave wireless terminals in a point-to-point link. This means that the master and slave terminals can be configured simply and easily through the uploading of the appropriate software. In the second Wipass point-to-point configuration, an access point, which is a hub station for a point-to-multipoint configuration, is used at one end of the link and a wireless terminal at the other. By changing the antenna of the access point from the omnidirectional antenna required for multipoint applications to a Cassegrain antenna, known for its high directivity and gain, we can achieve communication over a longer distance than is possible with the point-to-multipoint configuration. In the first configuration, using 2 wireless terminals, you can choose between QPSK and 16QAM modulation schemes. In the case of 16QAM, the transmission rate achievable is 32 megabits per second in both directions. The maximum range is a few kilometers. In the second configuration, using an access point and a wireless terminal, adaptive modulation of QPSK and 16QAM is used. The maximum transmission rate achievable is 46 megabits per second, and the transmission distance is a few kilometers. The maximum transmission distance can vary depending on the specified allowable unavailability, the rainfall, and the rain attenuation estimation method used. Two or more Wipass point-to-point communication links can be used in tandem, so allowing the transmission range to be extended. SNMP, or Simple Network Management Protocol, is used in the operation system. The functions provided include configuring access points or master and slave wireless terminals, monitoring the equipment and links, suspending radio transmission, resetting equipment, and carrying out several kinds of link tests. The operation system allows easy localization of a fault. The security measures incorporated include authentication and encryption. There is also a mechanism that permits only pre-registered wireless terminals to send or receive data. The key advantage of Wipass over conventional FWA systems is its low cost. In addition to making the wireless terminal small and lightweight, various details of the specifications were revised, and dedicated mounting brackets were developed to assist in installation. As a result, the cost of Wipass is only 1/5 or 1/10 of the cost of conventional FWA systems using quasi-millimeter waves. Now, let us look at several examples of how the Wipass point-to-point communication system has been actually used. The first example is that of a rural elementary school in Thailand. Wipass has brought a broadband environment to a school whose only previous communication infrastructure for access to the internet had been dial-up over the public telephone network. This is Chiang Rai, about 800 kilometers north of Bangkok, the capital of Thailand. Although rich in nature's bounty, the town suffered the effect of the digital divide. That is, it lagged behind in the availability of a broadband environment. Broadband access was brought to this elementary school by a Wipass point-to-point communication system that connects the school to a university standing on the top of a hill in the same town. This is the only university in the region that provides leading-edge education. The university has access to a broadband network via an inter-university network. The Wipass Master Wireless Terminal was installed on the roof of the university, while the slave was installed at the elementary school, about 2.3 kilometers away. Now that it has broadband access, the elementary school not only uses the internet in its classes, but is also planning the introduction of e-learning by taking advantage of the inter-university network. The school expects to reap significant educational benefits from the new broadband environment. The school also highly appreciates the small size and light weight of the wireless terminal and the ease of maintenance made possible by the LED status on the wireless terminal adapter. What you have just seen is a typical and simple example of the provision of broadband access capability by using Wipass to establish a point-to-point connection. It also illustrates how easily Wipass can expand a broadband environment, originally designed for a specific organization, to the surrounding areas. The next example can be found on a farm in the Philippines. A Wipass point-to-point communication system was used to collect data from various sensors on the farm. This trial was carried out jointly by the Advanced Science and Technology Institute, or ASTI, in the Philippines, and an NTT Group company. This is the trial site Phil Rice, an institution which studies rice growing in the Philippines. Wipass was used to send data on temperature, humidity, the amount of sunlight, and the water content of the soil, as well as still pictures of crops, from a field server installed at the pilot farm to the research building about 300 meters away, where the data was analyzed. This trial confirmed that this type of network can offer an effective solution in advancing the use of IT in agriculture in the future. By using links connected in tandem, it is possible to avoid obstacles on the path or extend the transmission distance. This makes it possible to collect data from field servers scattered over an expansive area of farmland. The next example we will look at is very experimental in nature. The site of this trial is in Chile, South America. This is the world's largest open-pit copper mine, Chuquicamata Copper Mine, 4 kilometers across and 800 meters deep. Huge trucks are constantly moving around, and there's the occasional sound of blasting with dynamite. In order to ensure safety and provide communication with the drivers of heavy machinery, it was desired to build a LAN within the mine as a means of sending various kinds of data, including images of different views of the mine. Since a small power wireless LAN alone cannot cover the entire area of this vast mine, the company chose to combine a wireless LAN and Wipass. Both point-to-multipoint and point-to-point configurations have been used to connect monitoring cameras and a wireless LAN. An access point and a master wireless terminal have been installed in the control center. By making use of such configurations, the entire area of the huge mine has been covered. The last example we will look at is a case of using a Wipass point-to-point communication system in place of an optical fiber as a wireless backhaul link. This is a municipal IP data communications network covering the major part of a provincial city with a population of a little less than 50,000. The network consists of an optical fiber network and several dozen Wipass base stations. Wipass point-to-point communication was selected as a means of extending the network to the surrounding areas where barriers such as rivers, railways, and farmland prevent the installation of optical fibers. A Wipass point-to-point configuration consisting of an access point and a wireless terminal has been used to permit high-speed communication at a maximum transmission rate of 46 megabits per second. We have seen several examples of the use of the Wipass point-to-point communication system. It is useful not only for building a broadband network, but also for providing high-speed bidirectional communication easily and at low cost in areas where, for various reasons, wireless communication is the suitable option. Whether you want to provide a link between LANs in separate buildings, or a last-mile solution for broadband internet access, or you need to provide leased lines or backhaul links for public wireless LANs, the Wipass point-to-point communication system can dramatically change the way you do business.